Have you ever thought about interstellar travel? It sounds romantic to journey to other worlds towards the stars, but actual reality might disappoint you. The current maximum speed of the Voyager 1 probe is 10.5 miles per second. Even at this speed, the journey to our closest star, Proxima Centauri, would take about 74,600 years. Now imagine that one day humanity creates spacecraft capable of traveling close to the speed of light. About 186,000 miles per second. Sounds impressive, or maybe just impossible. But even that wouldn't be enough, because even at that speed, if we wanted to leave the Milky Way galaxy, it would take around 100,000 years. And what if we wanted to go further and consider not just interstellar travel, but intergalactic travel as well? That's where an even more serious problem emerges, namely a gigantic cosmic anomaly that was discovered in 2013. While conducting research, a group of astrophysicists found that our galaxy is surrounded by a massive cosmic void, which, according to the laws of physics, shouldn't exist. This isn't just a region with a lower matter density, it's one of the largest known cosmic voids. Its diameter could reach 2 billion light-years. If it were filled with galaxies, it would fit more than 20,000 Milky Ways lined up from edge to edge. The scale of this anomalous region is truly staggering. Light would take 2 billion years to cross it. But perhaps the most shocking part of this discovery isn't the size of the void, it's our location. We're most likely located close to its center. Our galaxy seems to lie at the heart of a colossal funnel, and, as scientists note, this could seriously affect our understanding of the structure of the universe. But if we really do live in a special, isolated corner of space, an inevitable question arises: what lies beyond it? Could the space beyond this void be fundamentally different in density, in structure, or even in the laws of physics that govern it? Today, more and more scientists are wondering, what would happen if we could cross that boundary and see the universe as it reveals itself on the other side of the void? The universe is larger than we can comprehend. Currently, we know there are at least 100 to 200 billion galaxies out there that we can now see. But it's a good chance there could be 2 trillion galaxies or more in our observable sphere alone. We just can't see them. We all know that the observable universe is estimated to be approximately 13.7 billion years old. This is defined by the speed that light travels, and astronomers came up with the age of the universe by measuring light that has reached us from the oldest and most distant stars. We define observable space by the light that has reached the Earth and can be seen. Cosmologists estimate the oldest photons we can currently see have traveled a distance of 45 to 47 billion light-years since the hotly debated Big Bang theory. This means that our sphere of observable universe is around 93 billion light-years across. To give you an idea how big that really is, 1 light-year, which is the unit of astronomical distance that light travels in 1 year, is 9.46 trillion kilometers. With that in mind, the big question is, how can the universe be 93 billion light-years across if it's only 13.7 billion years old? This means that the universe could be older, much more than 14 billion years. We know that anything further away from the light that we see from the beginning of the universe, or the cosmic Big Bang, hasn't had enough time to reach us. Thus, we can't see what's out there. It's pitch black. But does this mean the edge that we can see is all there is? The truth is, there could be a lot more out there. Ever since the Big Bang, the cosmos has been growing at an increasing rate. It was Edwin Hubble that discovered that the universe is expanding and that all galaxies are moving away from the Milky Way. Not only are these galaxies moving away from us, but the farther away they are, the faster they're flying away from us. In fact, Hubble found that for each additional megaparsec of distance, galaxies receded 500 kilometers per second faster. This became known as the Hubble constant, and the area of our observable universe is called the Hubble volume. One thing we need to understand is that the word observable in this sense doesn't refer to the capability of our current modern technology to detect light or other information from an object, or even if there is anything to be detected. Observable here in this case refers to the physical limit of the speed of light itself, which is its maximum speed. When talking about the distance of anything in space, we're also talking about time. Looking up into the night sky is a little bit like time traveling. All those glittering stars in the night are only snapshots of what those stars looked like in the past. Just think about it. Some stars and other objects in the cosmos are so far away that their light can take thousands to millions of years to reach planet Earth. And if there is something beyond the edge of the observable universe that we can't currently see, it means that these objects are so far away from us that their light still hasn't reached us. The cosmic horizon is the measure of the distance from which we can retrieve information. But is there something out there past what we can see? It's really tough to answer this. However, to get some idea if there is something out there, we need to take into consideration the curvature of the observable universe. The thing is that astronomers aren't really sure if the universe is infinitely big or just vastly huge. In order to measure the universe, astronomers look at its geometric curve on large scales, which tells us about its overall shape. If the universe is perfectly geometrically flat, then it can be infinite. But if it's curved like Earth's surface or is like a bubble, then it has finite volume. Current observations and measurements of the curvature of the universe show that it's almost perfectly flat, like a sheet of paper. That would indicate that it must go on forever. We know with some certainty that there is more universe out there beyond the boundary that we can see. Astronomers believe that space could be infinite, with more of what we already see, and it's probably distributed the same way as it is here in the observable part. Now here is one of the mind-blowing things to think about if the universe is infinite. If this were to be true, then you wouldn't just find stars, different planets and galaxies. You would eventually find every possible thing. Think about that for just a moment. You would find everything. If you went far enough, you would find a solar system identical to ours in every way, including a planet Earth and your twin, except that a copy of you might have eaten cereal this morning instead of a version of you that skipped breakfast altogether. It's a fact that some cosmologists think if you go far enough, you would eventually find another Hubble volume that is identical to ours with a version of yourself mirroring your every action. Now, while that might sound impossible to what our minds can grasp and understand, there is something else very strange and unexpected that was discovered by astronomers in 2008. They found that galactic clusters were all streaming in the same direction at over 3,218,688 kilometers per hour. It's a phenomenon called dark flow. This movement of galaxies defies all predictions about the distribution of mass throughout the universe after the Big Bang. So what is the mysterious gravitational pull on all these galaxies? One possible cause could be massive structures that are outside of the Hubble volume that are exerting a massive gravitational influence. In simpler terms, massive objects with a huge gravitational force pulling everything towards them. If true, this would mean that the structure of the infinite universe beyond our view is not uniform. No one knows what these structures could be. It's possible they're aggregations of matter and energy on scales we can barely fathom, or they could be gravitational forces of other universes. Speaking of massive structures, there is one in our universe that's so big that it shouldn't even exist. In fact, it's the biggest structure in the observable universe. It's called the Hercules Corona Borealis Great Wall, and it measures 10 billion light-years across. It's so big that it makes up 11% of the observable universe. To put this further into perspective, if you were traveling at the speed of light, it would take you 10 billion years to get from one end to the other. So why shouldn't it exist? The problem is that astronomers have no idea how this Great Wall formed only a few billion years after the Big Bang, and could have grown so big in such a short time. This means there could be giant structures like these out there pulling on everything, including space. One day it could very well rip apart the fabric of space-time itself. And speaking of gravitational forces from other universes, some astronomers believe that the post-Big Bang expansion of the universe created bubbles that formed in the structure of space, and each of these bubbles is an area that stopped stretching along with the rest of space and formed its own universe with its own physical laws. In this scenario, not only is space infinite, but each bubble is also infinite, because you can store an infinite number of infinities inside a single infinity. To make that seem a little more clear, even if you could breach the boundary of our bubble, the space in between bubbles is still expanding. So in the reality of space-time, you could never get to the next bubble, no matter how fast you traveled. But will we one day have the technology to see what is beyond the edge of the universe we can now see? The sad reality is that light from any object outside the Hubble volume will never reach us, because the space between us and it's expanding too quickly. For example, we may never see what a galaxy looked like 10 billion years after the Big Bang. This doesn't have anything to do with our limited technology, but instead the physical limits of the speed of light itself. This means that any light emitted by objects at a distance of 19 billion parsecs will never reach the Earth. As time goes on, more and more points in space will have time for their light to reach us, which means that the observable universe is still increasing in size, and that also means that the age of the universe will increase. That said, you might think that one day, if humanity is around long enough, the entire universe would become observable to us. But since space in the universe is continually expanding, the distance between us and everything else becomes farther and farther each second. However, the James Webb Space Telescope will be able to look farther into space, will look backward in time, and just may give us more answers to what else exists out there. In a sense, it's a time machine, and we'll be able to see further into the past. With that said, we want to know what you think is out there. And do you believe that the universe is infinite, and there is someone just like you somewhere billions and billions of light years away? Let us know what you think, and if you have any ideas on what you'd like to see next, then let us know. Thanks for watching.